Good afternoon, ladies and gentlemen. It is indeed a great pleasure to be here at the Canadian Embassy, a marvellous venue to commemorate the 75th anniversary of the Tizard Mission. I'd especially like to thank the Office of Naval Research for all the hard work they put into organising this symposium, so thank you very much, Matt, and all your staff. And a special thank you to Canada for her assistance all those years ago in facilitating the UK's engagement with the US. Not a lot of people understand exactly just how that played out. But as many of you will know, Tizard didn't actually travel directly to Washington, DC. He bounced around a little bit. He landed in Newfoundland, he went to Montreal and Ottawa, and he was joined in Washington, DC by Britain's scientific attaché in Ottawa, the head of Canada's National Research Council, and the Master General of Canada's Ordnance Office. They were to strengthen the mission and also to lay the foundations for scientific cooperation between Canada and the US. In my remarks to you today, I'm probably going to cover quite a bit of the ground that John's just covered, and I think that's quite understandable, and I think it's something worth telling again from a slightly different perspective. So I'm going to mention Vernon Gibson shortly. But in my remarks today, I'm not going to belabor the historical significance of the Tizard mission itself, its impact on World War II, or the many technological innovations that came of it. You'll hear more about those topics later this afternoon from speakers more qualified to discuss them. Instead, I want to talk about how the Tizard mission began the development of what we now know, 75 years later, as the Defence Science and Technology Enterprise. I hope that by the time I finish, you will agree that in our global environment of proliferating threats and an increasingly narrow technological advantage, that there is no better time to learn from Henry Tizard's visionary leadership. Visionary, not just because he understood the crucial influence that civilian technology would have on the battlefield, although he certainly did, and not because he possessed that perfect melding of drive, people skills, and technical insight, though he had those too. His real and lasting contribution was to show that the way we develop technology is just as important as the technology we develop. In the 1940s, it was a massive leap of faith to recognise that aspects of defence could be led by a civilian scientist, especially so in the UK, and probably would have been true anywhere, but it really was a massive leap of faith at that time. But Henry Tizard showed that it could be done. After the war, he returned to government service and fought hard for the establishment of a science organisation within the new Defence Ministry. A fight, I'm glad to say, he won, not least because without it, I wouldn't be standing here as MOD's Chief Scientific Advisor. Henry Tizard was the first, holding the position from 1947 until his retirement in 1952. And there has been a dedicated scientific advisor to the Ministry of Defence ever since. In America too, the legacy of the Tizard mission is clear, and Dr. Holden has touched on this quite extensively. In 1940, only the Navy had a dedicated research and technology organisation drawing on civilian scientists. By the early 1950s, the other services had followed suit. And outside the DoD, the Lincoln Laboratory of MIT, of which Secretary Carter has previously been a board member, has its roots in the radiation lab, which demonstrated and developed most of the microwave radar technology used by the Allies during the war. I want to mention a revered name, the same one that Dr. Holdren's mentioned, is revered in the annals of 20th century science, that of Vannevar Bush. In many ways, he was Tizard's counterpart in America. He'd been made chairman of the National Advisory Committee for Aeronautics at the outbreak of war in Europe. He recognised that the United States was in need of an organisation with overall control of research and development for the application of science in wartime. Vannevar Bush went out and canvassed the opinions of some of the most powerful academics in the US at that time, people like Carl Compton, president of MIT, James Conant of Harvard, and Frank Jewett of Bell Labs. In 1940, the year of Tizard's mission, an act of Congress was drawn up to establish the National Defence Research Committee, consisting of 12 members appointed by the President. The National Defence Research Committee was designed to bring together scientists, industry, and the military, quote, to correlate and support scientific research on the mechanisms and devices of warfare. Alfred Loomis, a wealthy financier and gifted amateur physicist, was also to play a key role. With his own money, he had built a state-of-the-art laboratory at Tuxedo Park, some 40 miles or so up the Hudson River from New York City. He was chosen by Compton to head up D1, the microwave subcommittee set up to oversee the research and the search for battle-ready microwave systems. The Tizard mission is perhaps most famous for bringing the cavity magnetron from the University of Birmingham. That's Birmingham in the UK, not Alabama. However, it is worth remembering that numerous ingenious innovations were necessary to bring the fledgling cavity magnetron to the point of deployment, and Loomis was central in that endeavour. It's one thing making a discovery and establishing proof of concept. There's an awful long way to go still to bring something all the way through to deployment. In many respects, the legacy of Vannevar Bush and Henry Tizard is the enduring philosophy of how to resource and organise science, engendering partnership between academia, industry and government to develop, demonstrate and deploy new technologies. It's a philosophy that is just as important today as it was back then. Beyond their institutional legacy, Tizard and his North American partners brought about a catalysing moment in the transatlantic relationship. Tizard's mission at that time may have been a desperate act of trust, but it was the seed from which has grown a collaborative relationship in science and technology that is unmatched anywhere in the world. Tizard understood that innovative technology is worthless if you can't develop and field it, and that by working with our allies to pull together academia and industry, drawing on each other's strengths, the end result in military capability, interoperability, and value for money is much more than the sum of the parts. We can track the jointly developed fruits of the Tizard mission through time, from airborne radar to modern missile defence, from the jet engine to the F-35. Today, US and UK defence scientists deliver more than $450 million of collaborative science and technology annually. We co-fund academic research and we work in each other's laboratories, and that is just bilaterally. There are many more millions of dollars of important science and technology delivered each year through the Technical Cooperation Programme, of which Canada, the UK and US are founder members. But now is not the time to rest on our laurels, either alone or collectively, especially in the light of recent events. The past few years have been dominated by the need to support operations, and our scientists and engineers have been instrumental in rapidly fielding new capability. But the role of science and technology is broad and multifaceted. To maintain our technological advantage into the future, we must adapt our approach to innovation today. The ingredients for success now are no different than they were in the period leading up to the 1940s. It comes down to the best brains working on the most important challenges in the best equipped laboratories and workshops, and they must be underpinned by a funding pipeline that takes the seeds of discovery through development and demonstration through to deployment into commercial products or military capability, often both. Corralling all these ingredients together is by no means easy, but positive steps are being taken on both sides of the Atlantic. I can see the spirit of Henry Tizard in the DoD's third offset strategy and in its efforts to build lasting partnerships with non-traditional industry. During his recent visit to London, Secretary Carter and Defence Secretary Michael Fallon issued a joint challenge to strengthen our bonds in research and technology and to bring forward proposals that match the ambition of the Tizard mission. I firmly believe that it is only by doing so and doing so together that we can continue the growth of defence science and technology as part of a wider international innovation ecosystem. The recent announcement in the UK of a major new government drive on innovation and technology in defence is complementary. And as a former industrial chief scientist, I know how valuable industry engagement is to MOD. The £70 million funding package recently announced by the UK's Defence Secretary will start to transform our approach to innovation over the next 5 years. It will ensure UK defence is open to innovative ideas and technologies from the widest range of sources across industry and academia. I'm excited to have a part to play in these initiatives as they mature. I'm confident that by leveraging each other's efforts, deepening our collaborative research and finding new approaches to technology development and integration, we can nurture the next generation of game-changing innovations. Whether that is bilaterally, or through mechanisms such as the Technical Cooperation Programme, we must jointly put our cards on the table as Henry Tizard did 75 years ago. We must be sure that we can work as productively together in the future as we have done in the past. Thank you.